I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
With its historic investigation of Neptune, Voyager achieved an unimaginable finding on August 25, 1989, the first spacecraft visit to the far-off planet. What if, on its trip outside the well-known boundaries of our solar system, it comes across events that contradict the laws of physics? Join us as we investigate the mysteries left behind by Voyager's groundbreaking space exploration missions, which carried mankind into previously unexplored regions of space. Discovering the mysteries of the solar system's fastest storms beneath its serene, azure exterior lies a disorderly realm. The scientists are still baffled by that. The discovery of Neptune's great dark spot, a massive storm roughly the size of Earth, was among the most startling. The highest documented wind speeds in our solar system, 2,400 kilometers per hour, were attained during this storm. What's going underneath Neptune's surface is called into serious doubt by this. Do these intense storms have any hidden mechanisms or heat sources? Researchers uncovering the secrets of Neptune come across abnormalities in the planet's magnetic field that go against accepted science. What they are going to discover has the potential to completely alter planetary science textbooks and to upend our preconceived ideas about what is feasible in the frigid outer regions of our solar system. Unlike other moons in our solar system, Triton is unique. Its orbit around Neptune is counter to the planet's spin, indicating that it may have been caught from somewhere else in space, possibly the Kuiper Belt. Triton is a freezing world with unexpectedly high levels of activity. Triton is the coldest known object in the solar system, with temperatures as low as -235 degrees Celsius, although life nevertheless exists on its surface. Sharp ridges, a pinkish icetop, and nitrogen plains were observed by Voyager Two. The geysers, which send black plumes several kilometers into the sky and are probably the result of cold, volcanic activity, were the most amazing sight. These geysers provide evidence that heat may be produced deep into Triton, maybe as a result of Neptune's gravitational attraction. The surface of Triton, with its ridges and patches of smooth material, demonstrates to us that it is still dynamic and changing in its own peculiar way. It posed fresh questions even as it passed Neptune and Triton. What fuels the enormous storms on Neptune? How can the delicate ring arcs on it remain in place? What's going on beneath the cold surface of Triton? Scientists are still motivated to investigate the farthest regions of our solar system by these mysteries. While Voyager 2 bid farewell to Neptune, Voyager 1, its twin, was engaged in a distinct mission. Voyager 1 departed from Earth to explore space after stopping at Jupiter, Saturn, and Titan, the moon of Saturn. Reaching the furthest location impacted by the Sun required 32 years. As it drifted by Neptune in 1939, it took what is arguably the most iconic picture in history. Earth appeared as a small, light blue dot from a distance of 6 billion kilometers. Carl Sagan's description of this sight served as a reminder of how little and vulnerable our planet is in the grand scheme of cosmos. When these aged probes were first launched in 1977, their primary purpose was to investigate the outer planets. However, they have pushed into interstellar space, considerably exceeding those objectives. Now, long after we lose communication with them, they will continue their mission as they drift toward far-off stars. In almost 40,000 years, Voyager 1, now traveling at 17 kilometers per second, will pass close to a star in the Camelopardalis constellation. Following a different route, Voyager 2 will pass over Ross 248, a star, and thereafter get close to Sirius, the brightest star in our sky. The golden recordings that both Voyagers are carrying are chock full of sounds and visuals of earthly life, including music, ambient noises, and multilingual greetings. These recordings serve as a picture of our current state of affairs as well as messages for hypothetical extraterrestrial civilizations. The tale of humanity's search for knowledge is carried by the Voyagers as they drift farther and further away, serving as a constant reminder of our amazing adventure and the limitless opportunities that lie ahead. The information that the Voyager spacecraft returned altered our understanding of the distant planets and demonstrated the true complexity of the heliosphere, the region that surrounds our solar system. Their findings have opened the door for new missions and demonstrated the necessity of using increasingly more sophisticated spacecraft to investigate the furthest regions of our solar system and beyond. These expeditions pique our curiosity about what's out there and serve as a reminder of how vast the cosmos is. Voyagers 1 and 2 are prime illustrations of our curiosity. They inspire us to seek for that which we do not yet comprehend and to look beyond what we now know. The Voyagers represent humanity's incredible achievements and our continuous search for our place in the cosmos as they go farther into space and beyond our solar system. They will continue to inspire explorers, scientists, and engineers in the years to come. The Voyager's voyage laid the groundwork for future space travel, inspiring us to set higher goals and dream greater than before. These spacecraft, which are still in use today and are traversing vast expanses of space, serve as a constant reminder of humanity's desire for exploration and knowledge. This was crucial as transmissions between Earth and the Voyagers take hours to travel, and the spaceship needed to be able to handle issues and complete jobs without waiting for orders. Our knowledge of planets like Jupiter, Saturn, Uranus, and Neptune was constrained by the capabilities of telescopes prior to these trips. The Voyager spacecraft provided us with our first up-close view of these enormous planets, illuminating their whirling atmospheres, violent storms, and moons in ways never previously possible. For instance, the enormous storm known as Jupiter's Great Red Spot was displayed in amazing clarity. Scientists were able to learn more about Jupiter's magnetic field and its interactions with its moons because of the spacecraft's ability to record the motion of its clouds. Astonishing detail was also discovered about Saturn, the planet known for its rings. The Voyager's crisp photographs demonstrated the ring's structure, gaps, and interactions with Saturn's moons. The surprises, however, didn't end there. Scientists now have a better knowledge of the atmospheres and geology of Uranus and Neptune because of their up-close observations of the planet's peculiar tilt and its powerful storms, which include the Great Dark Spot. Strong winds and a continuously shifting environment were unique features of Neptune that made them exceptionally interesting. Our next major adventure, traveling into the stormy atmospheres of Uranus, where more cosmic riddles lie, begins with the investigation of Neptune. Voyager Mission Insights. The missions also revealed significant information on the moons that circle these planets. For instance, the thick coating of ice covering Jupiter's moon Europa may conceal an ocean beneath, which begs the issue of whether life may live there. Methane lakes and a thick atmosphere were detected on Saturn's moon Titan, while geysers were identified on Neptune's moon Triton, suggesting that the moon's surface may still be active geologically. New moons and weak ring systems, such as the narrow rings surrounding Jupiter and Neptune, were also discovered by the Voyagers. We now have a better grasp of how planets and their rings develop thanks to these discoveries. They also offered crucial details on the magnetic fields of these planets, such as the tilted magnetic field of Uranus, which startled scientists and demonstrated how intricate these planets' interior dynamics may be. Ultimately, the Voyager project symbolizes humanity's ongoing quest to understand more about the cosmos and is not merely about scientific discoveries. Each piece of information that has been returned has increased our understanding and prompted additional inquiries. Voyager takes with it our insatiable curiosity and desire to explore the uncharted, even if it is now far from home. Scientists now have a whole new perspective on the inner workings of the planet and its deep interior activity because of Neptune's magnetic field. The spacecraft entered an area where space itself starts to alter and the solar system's outer edges start to lose their power. However, it did more than just vanish into thin air. It sent back crucial information from the most remote regions of our cosmic neighborhood. It monitored magnetic forces, unseen particles, and the thin atmosphere that exists between stars. This contributed to our understanding of the boundary between interstellar space and the solar wind from the sun. These findings helped us comprehend a hitherto undiscovered region of the cosmos and advanced our knowledge of the solar system's periphery. Despite being far outside of our solar system, the spacecraft continues to teach us new things. The information acquired helps scientists understand how planets develop, function, and interact with one another, laying the foundation for future expeditions. The most astounding aspect, though, is not yet over. The information returned serves as a kind of manual for upcoming space travelers. The accomplishments have altered space exploration in general as well as science. The lessons learned have a big impact on today's space missions. It established the bar for everything from keeping a spaceship operating over vast distances to communicating across billions of miles to maintaining equipment in the void of space. The New Horizons mission, for example, used technology and procedures enhanced by its success to approach Pluto. It demonstrated how difficult it is to communicate with spacecraft located millions or perhaps billions of kilometers distant, yet it is possible. It demonstrated that, even at great distances from Earth, large antennas and unique techniques for amplifying weak signals from deep space can be used to transmit back crisp data. However, the true test lay ahead. These methods became much more important for subsequently planned missions such as the Mars rovers or extrasolar probes. It made some of the most significant findings about the outer planets, Jupiter, Saturn, Uranus, and Neptune, when it came to planet exploration. Future expeditions should investigate the additional questions raised by the up-close perspectives. For instance, research on Jupiter's atmosphere and Saturn's rings led to further exploration of these planets' secrets by missions like Cassini and Juno. A map that has been established has served as the basis for learning more about our nearby planets. This one image came to represent our position in the cosmos and inspired curiosity about what else may exist. It increased the standard for space mission planning. Its accomplishment demonstrated the need of meticulous preparation and original problem solving. Since then, every spacecraft launched has profited from the lessons learned along the way, enabling future missions to be more equipped to face the challenges that lie ahead. Its legacy is being carried out by missions such as the James Webb Space Telescope, which seeks to probe much further into space to understand the formation of planets and galaxies. The biggest surprise, though, wasn't this. It also heralded in a new era of space travel. Europa Clipper, a mission to investigate Jupiter's moon Europa, is another one that was influenced by it. There could be an ocean under its frozen surface that might support life, according to scientists. Scientists are now looking for evidence of extraterrestrial life because of their curiosity about places like Europa, sparked by earlier discoveries about the moons of the outer planets. What was started is being expanded upon by future space missions that want to depart our solar system. As they continue to explore interstellar space, these next-generation probes will be collecting information about the uncharted regions of the cosmos. Its work serves as a foundation for the concepts and technologies guiding these missions, demonstrating the breadth of its influence. Beyond its contributions to science, though, it represents human curiosity and the urge to investigate. The golden recordings that were put on board, with audio and visuals from Earth, were dispatched with the expectation that intelligent entities might one day find them. These recordings serve as a constant reminder of our aspirations to establish contact with extraterrestrial life, even as it drifts further into space. We are genuinely curious about and yearn to communicate with intelligent species on other worlds. We wish to communicate our identities, cultures, aspirations, and future goals. They carry more than just scientific equipment when they leave our solar system. They also symbolize human desire. Their voyage demonstrates the progress we've made in our quest to comprehend space and our role within it. Their golden records, which contain messages that transcend Earth, stand symbolically for this dream. Our desire to connect with people beyond the stars is reflected in these recordings, a desire that keeps us motivated. With this understanding, we eagerly embark on a new period of adventure, wanting to see what is waiting for us over the horizon. Earth's salutations to the cosmos, the Voyager missions serve as a reminder that exploration is about more than simply discovering new locations. It's also about altering our perceptions of the universe and ourselves. These missions inspire us to keep searching farther, posing more challenging queries, and exercising fortitude when confronted with uncertainty. The golden recordings, which date back to the 1970s, are preserved in time. Their purpose was to demonstrate to anybody who would stumble upon them what life is like on Earth. There are 55 global greetings in various languages contained in the recordings. The variety of people and civilizations on Earth is demonstrated by these welcomes. The recorded music features both indigenous songs from throughout the world and classical compositions by composers such as Bach and Beethoven. The beauty of human ingenuity and the ability of music to unite people are both reflected in this music. In addition to the greetings and music, one may get a feeling of the nature of Earth through the sounds of thunder, birds, and whales, among other things. Additionally, there are 115 photos that depict many aspects of human existence, civilizations, landscapes, and scientific and technological advancements. That's not all, though. There is also valuable science and math knowledge in the golden records. The intention behind including this knowledge, along with data on DNA and our solar system, was to make it understandable to any sentient species. Scientists thought that science and arithmetic were universal languages that applied to all of space and time. This was more than simply a science experiment. It was an optimistic notion that we might communicate with sentient entities, even if they were light years away. The golden records capture the essence of the 1970s, when people were enthusiastic about the prospect of extraterrestrial life and reaching out to the stars. It is now extremely unlikely that any aliens will discover these documents. However, it hasn't prevented curious folks from asking. Discussions over the appropriateness of sending signals into space and the definition of communicating with extraterrestrial life have been spurred by the recordings. They now serve as metaphors for our curiosity and our desire to learn more about the world around us. They have stimulated the minds of philosophers, artists, and scientists alike, getting them to reflect carefully on the nature of humanity and our place in the cosmos. But that is not where the narrative ends. The golden records serve as a constant reminder of our common human experience even now. They stand for our unwavering ambition to surpass ourselves and go beyond. They still serve as an inspiration for fresh concepts and initiatives that investigate the potential for extraterrestrial life. Voyager 1 and Voyager 2 set the path for subsequent missions as they continue to journey. The information they return aids in our understanding of space and directs the development of future spacecraft intended for even more in-depth investigation. NASA's Interstellar Probe mission is one such initiative that seeks to go beyond of our solar system and into the interstellar medium. We will get additional knowledge about the edge of our solar system and the huge space outside thanks to this expedition. There's still more. A daring new project called Breakthrough Starshot intends to use strong lasers to launch small spacecraft to the nearest stars. The goal is to travel to other star systems in a human lifetime, testing the capabilities of current spacecraft and offering us a look at what space exploration may hold in store for humanity. NASA is also developing novel concepts that may alter our approach to space exploration. Their Advanced Ideas program is investigating methods for communicating across long distances and traveling at a quicker pace. These developments might help us overcome the major obstacles to traveling far beyond Earth, which will determine the direction of space travel in the future. But there are other difficulties as well. Collaboration between governments and commercial groups will be more crucial than ever as space exploration grows more complicated. Working together will be essential if we want to keep expanding the realm of what is feasible in space. The European Space Agency, ESA, and the International Space Station's joint efforts demonstrate how much can be achieved when people work together. Working together, we can overcome the many obstacles that come with spaceflight, and this collaboration fosters a common enthusiasm for discovery. Joining forces makes nations and agencies more resilient to the challenges of deep space exploration and expanding humankind's reach beyond our small corner of the cosmos. These collaborations foster the development of a common strategy for space exploration in addition to technological advancement. This collaboration ushers in a new era in which our natural curiosity drives us to investigate uncharted territory, a voyage that continues among the stars. Space missions are among of our most amazing accomplishments, influencing how we perceive the solar system and displaying our ambition to keep pushing forward. Voyager 1 and Voyager 2, launched several decades ago, are still journeying farther into space, carrying more than just scientific instruments. They carry the essence of human curiosity, ambition, and a never-ending hunger for knowledge. These two spaceships are representations of our common desire to explore the wide cosmos and venture beyond our current understanding. However, more than simply the information the Voyagers returned mattered. They have ignited a desire for space travel that keeps motivating younger people. Deep space research has reached a new height because of the inventive techniques and technology they created throughout their incredible voyages. Were Neptune and its moon Triton able to elucidate the existence of extraterrestrial life? How do you feel about this heavenly enigma? 45 years after it left Earth, Voyager 1, one of the most amazing space probes ever sent into space, is still sending us information from the edge of our solar system. It has gone into the strange world of interstellar space, farther than any item made by humans. The spacecraft has given us new information about the universe that we didn't have before. But recently, Voyager 1 sent back information that made scientists feel even more amazed, curious, and even worried. There was a strange object in space that it had found. Please remember to like and subscribe to our channel before we begin if you want to see more videos. Voyager 1 made the discovery as it passed through the heliopause, which is the line where the sun's impact ends and interstellar space starts. Voyager 1's main job has been to study this area between space and the transition zone. However, it recently found an object that it hadn't seen before, which makes us wonder what it could be. The object, which seems to be hiding in the cold, faraway reaches of space, has never been seen before in any science models. Its shape, size, and nature are still unknown, which has led to excitement and guesswork about what Voyager may first have seen. Scientists were interested in the object because early readings from the probe showed that it was sending out weak electromagnetic signals. Space signs that are electromagnetic can come from many places, like pulsars, quasars, or even the leftovers of very old cosmic events like supernovae. Voyager 1 saw something, though, that didn't seem to fit into any of these known events. It wasn't a normal pulsar or a known celestial body, and the signal it left behind pointed to something much stranger and more mysterious. The object's signal was made up of random waves of energy that seemed to be coming from a single location. There was no match between the pulses and the pulsars or quasars emissions, which are some of the brightest things in the universe. Instead, this new object moved around in strange ways, almost like it was reacting to its surroundings. The instruments on Voyager 1 picked up these messages as it went through a part of space that had looked mostly empty up until now. This added to the puzzle. The way electromagnetic waves work is one of the most surprising things about this finding. Scientists noticed that these waves had a frequency that had never been seen before in interstellar space. The waves weren't in the frequency range that you'd normally find in natural cosmic events, and they didn't look like radio bursts from known sources in space. This led to ideas that the object might be something completely different, maybe an event that makes us question what we know about astronomy and how interstellar space is put together. As experts try to make sense of the data, a number of options have come to light. One of the most interesting ideas is that the object might be made of a very strange kind of matter that doesn't follow the rules of physics as we know them. In theoretical physics, ideas about strange matter have been around for years, but they have never been directly seen. Voyager may first have picked up some strange signs that point to the presence of matter that interacts with the universe in ways that make current models less likely to be true. Some experts have also said that the item might be a piece of the early universe, left over from events that happened soon after the Big Bang. This could be the case, and the object could give us a unique look into the early universe, showing us how galaxies, stars, and planets formed. The finding is even more exciting because Voyager may first have found an ancient artifact that has never been studied before. Another interesting idea is that the object might have been made in a lab. Though the idea of technology from other worlds has been the subject of fantasy and speculation for a long time, the unusual nature of the signals Voyager 1 picked up makes people wonder about the chance of intelligent design. Could this be a probe or item that a culture from another planet left behind a long time ago? Some experts are thinking about this idea because there aren't any similar natural events. However, at this point, it's just a guess. If the object were man-made, it would be the first proof of technology from other planets, which could completely change how people think about their place in the world. If this kind of finding were made, it would mean that other civilizations have advanced technology and may have explored parts of the world that humans are just now starting to understand. Even though there isn't any direct proof to back this theory, the object's mystery has left the door open to this exciting idea. The fact that Earth is so far away from Voyager 1 makes the study more difficult. Since it is more than 14 billion miles away, the probe is out of reach for scientists to help it right now. Talking to Voyager 1 takes more than 20 hours each way, so any new orders or instructions to look into the object must be carefully thought out and carried out slowly. Additionally, Voyager 1's tools, even though very advanced for their time, are not able to provide a thorough study of such a faraway and unusual object. Scientists haven't let this technology limitation stop them from finishing their research. It is being tried to better understand the data that Voyager 1 has sent back by making new models and simulations. Scientists are looking for trends in the electromagnetic signatures to try to figure out what kind of information is being hidden and learn more about the item. But for now, the object is still a mystery. Voyager 1 is the only one who has seen it as it floats somewhere in the vastness of interstellar space. In the meantime, the discovery has sparked new interest in the larger goal of studying space between stars. Voyager 1 was sent into space to study the planets beyond the solar system's edge. However, its longer journey has opened up new areas of study in space beyond the solar system's edge. This object's finding shows how little we really know about the space between the stars. The stars and planets that make up our galaxy can be seen and understood in some ways, but the huge gaps in space between them are still mostly unknown. Voyager 1 found an object that might also tell us something about the basic nature of the world. It could be a part of a bigger structure in the universe that we haven't found yet, or it could give us new information about the forces that control the universe. Some scientists have even thought that the object might have something to do with dark matter or dark energy, two of the universe's stranger and less well understood parts. If this were true, the discovery would be a huge step forward in our understanding of how reality works. The fact that the object is located so far outside of the solar system makes us wonder how these kinds of things can form and survive in outer space. Was it something that came from inside the Milky Way, or could it have been something from another galaxy? Even less is known about intergalactic space, which is the huge empty space between galaxies. The item could help us learn more about what lies beyond our galaxy. It's possible that Voyager 1 has found an object from another galaxy. If this is true, it would be one of the first straight meetings with something from outside the Milky Way. As scientists try to figure out what the discovery by Voyager 1 means, one thing is clear: the world is much weirder and more complicated than they thought. When an unknown object is found, it pushes the limits of what people think they know and opens the door to a new age of travel and discovery. The discovery of the object, whether it's a strange form of matter, a relic from the beginning of the universe, or something completely different, serves as a warning that the universe still has a lot of secrets to be solved. This find is also proof of how the Voyager missions have left a lasting impact. Voyager 1, which was launched in 1977, has long since gone beyond the limits of its original mission, but it is still making important findings. A spacecraft created and built with technology from the 1970s is still making important scientific advances more than 40 years later. This shows how creative and forward-thinking the mission was. The fact that this item was found by Voyager 1 is another part of humanity's ongoing quest to understand the world. The run-in with this object also shows how important it is to keep funding space research. Voyager 1 found a strange item in outer space that could change the way we think about things. This shows how much we still need to learn. A lot of attention is usually paid to missions closer to home, like those that explore Mars or the moons of Jupiter and Saturn. This finding, however, serves as a reminder that the farthest areas of space may hold some of the most deep solutions to humanity's most important questions. Over the next few years, as Voyager 1 continues its trip and scientists look into the data more deeply, they may learn more about the object's nature, where it came from, and what it might mean. These will be looked into and talked about for a long time. Future space trips could even be made with the specific goal of learning more about interstellar space. These missions would use the most up-to-date technology to build on Voyager 1's groundbreaking discovery. For now, the object is still a riddle that scientists, experts, and regular people are all interested in. It's a sobering warning that the universe is still very big and not very well understood, even with all the progress in science and technology. Voyager 1's finding has opened a door to the unknown. People are now standing at the doorway, eager to find out what's on the other side. Finding this item also makes people think about their place in the universe in a more general way. Is humanity the only intelligent species in the universe? If so, could they make or come across things like the one Voyager 1 reported? Finding such a mysterious object makes us think not only about the world, but also about whether there is life beyond Earth and what that might mean for our future. One of the most interesting things about this finding is what part the object might play in the bigger picture of how the universe has changed over time. If this thing really does come from the beginning of the universe, it could help us understand how the first stars and galaxies formed. Astrophysicists are very interested in anything that can be used to learn more about the early stages of the universe's past, because a lot of it is still too dark to see directly. The discovery by Voyager 1 could be like a cosmic skeleton, giving us secret information about the world right after the Big Bang. Scientists could improve models that show how matter first came together to form the structures we see today by looking at things that came from the beginning of the world. For instance, the discovery could show how some cosmic structures, like galaxy halos, came to be, how dark matter helped shape the universe, or even how black holes may have changed the way matter was distributed in the early universe. If this item is from that time, it might have markings on it that tell us about these formative times and help us solve problems that have been stumping cosmologists for decades. Another important conclusion has to do with what interstellar space is really like. Voyager 1's trip into interstellar space in 2012 was the first straight way for experts to study this area. The heliopause, which is the line between the solar wind and the interstellar medium, wasn't well understood, and the area beyond it wasn't known either. Most of what we know about interstellar space comes from looking at stars and galaxies far away. Voyager 1 is the first spacecraft to take readings in real time from inside this mostly uncharted area. Finding the item brings up important questions about what might be in interstellar space. People have usually thought that interstellar space is mostly empty, with few particles, atoms, and cosmic radiation moving around. But the fact that Voyager 1 ran into this object says that space may not be as empty as was once thought. There may be more buildings, phenomena, or things living in these areas than was thought before. This discovery could be the first of many like it, which suggests that interstellar space has more matter than we thought. This matter could be the remains of long-dead stars or other kinds of cosmic junk. The finding by Voyager 1 could also lead to a new look at how interstellar matter affects the future of spaceflight for humans. Long-term projects could face both problems and chances if there are more things, particles, or events moving through space between the stars. A spacecraft going very fast might have to avoid these things, but they could also be used for study or exploring. Finding out about the things that exist between stars could even help design new ways to move things around. For example, interstellar objects could be used as markers or as supplies for long journeys. It's possible that the object found could be a new type of matter. This brings up the old question of whether the standard model of physics is good enough to explain how complicated the world is. In the past, the standard model was a good way to understand the basic forces and particles that make up the universe. But new findings from particle reactors and astronomical readings suggest that it may not be the whole story. If the item is some kind of strange matter, it would be direct proof of things that the normal model can't fully explain. This could lead to the creation of new theories that combine parts of general relativity, quantum physics, and even string theory in ways that help us learn more about the most basic parts of the world. Strange matter might be the key to understanding things like dark matter, dark energy, or how space-time behaves at the quantum level. These are all ideas that are just guesses right now, but if strange matter is seen directly, they could become much more real. The finding of the object could also lead to a fresh look at how matter works with the universe's basic forces. For instance, if this object is made up of subatomic particles that we didn't know about before or acts in ways that go against what we normally think about gravity and electromagnetism, it could help us learn more about how these forces work on a cosmic scale. In turn, this could have big effects on areas as different as particle physics, astronomy, and even the search for new energy sources. Finding this strange thing makes us think about more than just science. It makes us think about philosophy as well. People have long wondered if they are the only ones in the world, and this new finding adds to the discussion. There isn't any clear proof that the object is connected to life on other planets, but it's not impossible that it isn't. If the item is confirmed to be man-made or shows signs of having been planned, it would completely change how we think about the universe and our place in it. The thought of running into an alien treasure in deep space, especially on a spaceship launched from Earth, sounds like something out of a science fiction story. But this discovery makes it seem more likely that such a thing could happen. If there are or have been other societies in the universe, it makes us wonder how far they may have gone, what kind of technology they might have made, and if they left any signs of their existence in different parts of the universe. Whether or not the item is real, the fact that it exists is a warning of how much we still don't know. As a species, we are still just beginning to learn about our cosmic neighbors. The trip of Voyager 1 has taught us a lot, but it is still just one probe, and its old technology limits what it can do. Future missions might have better tools to find, study, and even deal with these kinds of things, which could help answer questions that are still open today. The finding is also a stark warning of how hard it will be for humans to become a species that lives across the stars. Even though Voyager 1 has done a lot of amazing things, it is still a lonely pioneer moving through space. People will have to face the facts of long-term spaceflight, interstellar dangers, and the unknowns that lie in the darkness between the stars if they ever want to follow in its footsteps. Another thing that the object might do is make us rethink how we describe and understand the idea of life in the world. Another possibility is that it is not a planet or star, nor is it an alien artifact. This could mean that there is a third answer that questions our ideas about what life, intelligence, or even existence looks like on a cosmic scale. The finding could lead to a lot more theory research into different kinds of life or intelligence that don't fit our Earth-centered ideas of what they are. For instance, some experts think that life might exist in forms that are so different from ours that we might not even know it is life. Some examples of these are animals that live in space, do well in places we think are not suitable for them, or even work on different physical principles than we do. The discovery of this object may not instantly lead to these ideas, but it does start a conversation about what kinds of things we should be looking for as we explore the world. In a real sense, the discovery also shows how important it is for space technology to keep getting better. Voyager 1 is an old spaceship that has done a lot more than anyone expected. However, there will come a time when it can't talk to Earth anymore. Finding this strange object shows how important it is to put money into more projects like Voyager that can build on its work and help us learn more about the universe. It's clear how important it is to make new spaceships that can keep exploring space between stars. It's possible that these future probes will last longer, carry more advanced equipment, and go farther and faster than Voyager 1. These kinds of projects could not only help us learn more about this object, but they could also help us learn more about parts of space that we can't reach now. As technology keeps getting better, it's possible that one day people will be able to send probes to other star systems that can reach them in our lives. These robots could have artificial intelligence on board, which would let them make choices on their own as they explore the unknowns of deep space. They could also be made so that they can look at things like the one Voyager 1 found in much more depth. The discovery could also make people more interested in trips that aim to bring back samples from space. This might seem like a far-fetched idea, but it is not impossible with today's technology. Sample return trips have already been done to the Moon, Mars, and comets and been successful. As people's skills improve, it's not impossible to imagine a time when spaceships could bring back samples from beyond the stars. These samples could help us figure out what the item is made of and where it came from by giving us a clear look at the materials and forces that shaped it. Finding the object also shows how important it is for countries to work together on space research. The tools and knowledge needed to discover new areas get more difficult as the distances get longer. The finding made by Voyager 1 is a reminder that understanding the universe is a goal for all of mankind, not just one country. Future attempts to look into objects between stars will probably need the help of many countries working together, sharing their science and technological resources to make it happen. People are also more interested in space science because of the mysteries surrounding the object. Many people around the world are interested in things they don't know, and Voyager 1's discovery taps into this deep human desire to learn more about the universe. Many people are already interested in this finding. Amateur scientists, space fans, and even people who don't know much about science want to know more about what lies beyond the solar system. This makes us remember that space travel isn't just for experts, but for people from all walks of life as well. One of the first things that researchers are thinking about is how this finding might change the way we think about the universe, especially outer space. People used to think that the vast spaces between stars were lonely and mostly empty, but Voyager 1's discovery hints that interstellar space may be more complicated than we thought. For many years, scientists thought that the environment would stay mostly the same beyond the heliopause, which is the line where the solar wind stops being the main force. They thought that cosmic rays, interstellar dust, and scattered gas would be the main forces. But the fact that an object can be found there goes against these ideas and says that interstellar space could be home to many strange things. We can see from Voyager 1's discovery that this part of space is home to more than just cosmic radiation and particles. It may also be home to things and forces that we are just starting to understand. The fact that these kinds of things might be pretty common makes us wonder about the processes that make them. How do these shapes appear out of nothing? Are they leftovers from events in stars or galaxies, or do they come from something else in the universe that we haven't seen yet? The finding made by Voyager 1 might only be the tip of the iceberg. This means that the huge gaps between stars could hold a lot of stuff that hasn't been seen before. Astronomers will probably look at and improve models of how the interstellar medium moves as they try to find answers. These models try to show how gas, dust, and radiation behave in the space between stars. If things like the one Voyager 1 found are more common than scientists thought, they might have to rethink how these kinds of materials interact and come together in space between the stars. Current models are based on the idea that forces like supernova blasts, stellar winds, and the gravitational pull of faraway stars shape the space between the stars. But if there are denser or more organized things in this medium, we would have to change how we think about how matter acts when it is not affected by a solar system. The find could also help us understand cosmic magnetic fields, which are very important in creating the space between stars. These fields are made by charged particles moving through space. The birth and death of stars and the movement of galaxies can change these fields. The way things like the one Voyager 1 found interact with the magnetic fields of interstellar space could help us understand how these unseen forces help organize matter on a cosmic scale. It's possible that learning how magnetic fields affect strange things could lead to new discoveries about spacetime itself. Magnetic forces, in particular, could make it impossible for anything to live in space between the stars. Voyager may first have found a magnetic signal that is unique to it, or it may have interacted with space in a way that lets it keep its shape over long distances. We might learn more about how matter, energy, and electric forces behave in the universe's farther away and less studied areas if this turns out to be true. It also makes us wonder if these interactions have anything to do with the creation of bigger structures in space, like nebulae or the threads that connect galaxies. Another interesting theory is that the object Voyager 1 saw could be a cosmic rogue, which is a space rock that doesn't belong to any star or galaxy and just floats around. Planets and stars that go their own way have been thought of for a long time. They are sometimes called nomads of the cosmos. It is thought that these objects formed inside solar systems but were thrown out by gravity forces or other violent events, where they are now drifting through space by themselves. Could this thing be an errant object that's going around the galaxy without a clear home? If so, studying it could give us unique information about these hard-to-find objects. It might even help us figure out how many of them there are in the Milky Way and whether they have any effect on how the galaxy has changed over time. Rogue objects are very interesting because they make us question the idea that stars and planets need a solar system to exist. How do these things stay alive in the cold, empty space without the light and heat from a parent star? Do they still have parts of their original system, or have they changed to survive in the hard conditions of interstellar space? Scientists may look into these questions with more energy now that Voyager 1 has found an unknown object. The probe's data may eventually help prove the existence of more wandering celestial bodies. The finding by Voyager 1 could also lead to completely new kinds of cosmic events that scientists have not yet seen. The world is full of strange things and forces, and many of them are still just ideas. This finding could lead to the discovery of things that don't fit our current ideas of what stars, planets, or even black holes are. Dark matter is a material that makes up about 27% of the universe but has never been directly seen. This could be a type of dark matter. Dark matter doesn't give off, absorb, or reflect light, which makes it very hard to find using normal scientific means. If this object is made of dark matter, it could be the first clear proof of this hard-to-find substance, giving us a look into one of the biggest mysteries in the world. The fact that dark matter might be linked to this finding makes things a lot more important. People think that dark matter interacts with normal matter through gravity, but other than that, not much is known. It is very important for keeping galaxies together and has an effect on how they form and how they are structured. If Voyager 1 finds an object made of dark matter, it will give scientists a chance to study this matter in more depth that has never been seen before. Researchers might finally start to understand what dark matter is and how it affects the universe by looking at how the object behaves, how it interacts with particles around it, and how it affects space close by. On the other hand, some experts are thinking that this object might be a black hole that is very different from the ones we know about, maybe even a primordial black hole. Primordial black holes are made-up things that might have existed right after the Big Bang, when the universe was expanding very quickly. Unlike normal black holes, which are made when stars collapse, primordial black holes might have been made when the density of matter changed quickly at the start of the universe. If this thing really is a primordial black hole, it might be a leftover from the very beginning of time, giving us a unique look into the early stages of the universe's formation. Looking at something so old could help us understand the basic forces that formed the universe, like how gravity and quantum physics worked together in the beginning of the universe. People also think that primordial black holes might help explain dark matter because the amount and location of them could explain some of the mass that we can't see yet. The discovery of one in outer space would be a huge step forward in our knowledge of the universe's early times and help us make connections between events that happened billions of years ago. The fact that Voyager 1 found this object also makes people curious about what lies beyond interstellar space. The probe is going to intergalactic space, which is even less known and explored than the space between stars. It is thought that intergalactic space is even less dense than interstellar space, with very few hydrogen and helium atoms spread out over very long distances. Still, if things can exist between stars, then it makes sense that similar or even stranger things could exist between galaxies. The present path of Voyager 1 could take it to these faraway worlds in the future. Who knows what secrets might be waiting there? Exploring space between galaxies and maybe finding more things like the one Voyager 1 found could completely change how we think about how galaxies talk to each other. People often think of galaxies as separate islands in the vastness of space, but they are actually linked by huge structures made of dark matter and gas, which are called cosmic filaments. People think that these strands are very important for how galaxies form and change over time. If there are things or events in intergalactic space that we haven't seen yet, it could change what we think we know about these huge cosmic structures and how they affect the big picture of the universe. There may be unknown things in intergalactic space, which also makes us think about the future of space travel. Even though traveling between stars is already a big dream, traveling between galaxies is even bigger. It would take millions of years for even the most powerful spaceship we can think of to travel between galaxies because they are so far apart. Finding new items in intergalactic space, on the other hand, could pave the way for further research. If there are more structures or events spread out between galaxies, they could be used as stopping places for long-term journeys, giving scientists a chance to study them and maybe even take resources from them. Cosmos is full with secrets, extending from the backyard of our own solar system to the far-off beaches of the cosmic ocean. That's how it's always been, a spooky place full of mysteries and mysterious occurrences that will give you the chills. Now, on board Voyager 1, one of the most famous NASA spacecraft of the 20th century, strange things are happening in the vast emptiness of space, billions of miles from Earth. After 50 years of continuous flight, the most distant spacecraft ever built by humanity is still in operation. What's even more odd is that there are no indications of a malfunction or anything. NASA scientists are frantically attempting to determine the cause of this odd signal. What precisely has occurred, then? What may this terrifying signal entail for the rest of us here on Earth? Come us as we delve deeply into Voyager's historic journey to date as well as the recent, horrifying signal in deep space that has baffled scientists and experts. Voyager 1, which was launched on September 5, 1977, was designed to map the outer solar system with a focus on the gas giant planets Jupiter and Saturn as well as Titan, Saturn's moon. Launched in the same year as its twin, Voyager 2, it had a somewhat different mission to study the outer planets before reaching the end of the solar system. NASA was at its peak in those years. NASA had won the U.S. space race and successfully landed men on the moon a few years prior. The engineers at NASA were the world's envy. Both Voyagers had to travel through the asteroid belt, which is made up of rocks and junk circling the Sun, in order to reach Jupiter and Saturn. They had to withstand radiation from Jupiter, cosmic rays, and other space dangers. However, the two spacecraft arrived without any problems and started their extensive solar system trip. Many planetary scientists still rely on the unusual photos taken by the spacecraft's wide-angle and narrow-angle cameras, making their findings the stuff of folklore. Before the Voyager twins embarked on their amazing multi-decade journey of the large planets, mankind had only a rudimentary awareness of the solar system's far-off worlds, including Jupiter's tumultuous atmosphere, Saturn's shifting ring, Uranus' tilted axis, and Neptune's great dark spot. The profound findings opened our eyes to a universe never before seen. Voyagers 1 and 2 captured the outer solar system in all of its beauty through hundreds of photos, revealing it for the first time. 4 decades ago, early in their journey, the Voyagers stunned scientists with their first up-close pictures of Jupiter's and Saturn's moons, exposing the presence of active volcanoes and fractured ice fields on worlds that astronomers had assumed would be as crater-pocked and lifeless as our own moon. In particular, 546 days after launch, in March 1979, Voyager 1 arrived at Jupiter. In July of the same year, Voyager 2, which had a different course, arrived. The Vidicon cameras on board both spacecraft were built to be reliable platforms for generating full-color pictures through the employment of red, green, and blue filters. Their rotational velocity is more than 15 times slower than the crawl of a clock hand, so they rarely spin at all as they move across space, reducing the possibility of fuzzy pictures. The Voyagers captured almost 33,000 images of Jupiter and its satellites in total. It seems like each picture revealed something new. Rings around Jupiter. One of Jupiter's 53 known moons, Europa, has an ice covering that was shattered and believed to be more than 60 miles thick. A gravity assist gave the spacecraft a send-off push of 35,700 miles per hour as they exited the Jupiter system. They couldn't have escaped the Sun's gravitational pull and entered interstellar space without it. The Voyagers split off at Saturn. After dodging billions of dust grains as it navigated Saturn's rings, Voyager 1 passed Titan, an orange-shrouded moon, and continued northward out of the planet's orbit. Alone, Voyager 2 proceeded to Neptune and Uranus. Voyager 2 discovered 10 additional moons around Uranus in 1986, adding the planet to the expanding list of planets with rings. However, the Space Shuttle Challenger's premature explosion after launch eclipsed Voyager 2's discoveries, which came just 4 days after the spacecraft's closest approach to Uranus. The 7 members of the Challenger crew perished, among them Krista McAuliffe, a New Hampshire high school teacher who was slated to be the first civilian astronaut. After 3 years, Voyager 2 observed the fastest wind speeds of any planet in the solar system, reaching up to 1,000 miles per hour while cruising at a distance of around 2,800 miles above Neptune's blue methane atmosphere. Triton, the biggest moon of Neptune, has a surface temperature of -391 degrees Fahrenheit, or -235 degrees Celsius, making it one of the solar system's coldest locations. 5 miles into the moon's atmosphere, nitrogen gas and powdered particles were ejected by ice volcanoes. If Carl Sagan hadn't been an astronomer on the Voyager 2 imaging crew, those pictures of Neptune and its moons would have been the last that either spacecraft took. After the official grand tour was over, NASA intended to switch off the cameras on both probes. The project had officially been renamed the Voyager Interstellar Project, although it had been prolonged in the hopes that the Voyagers would reach interstellar space. After Neptune, there would be nothing but the unending emptiness and seemingly far-off stars for picture opportunities. NASA authorities were pushed by Sagan to have Voyager 1 send out one more batch of photos. Thus, the probe pointed its cameras back toward the inner solar system on Valentine's Day of 1990 and captured 60 last images. Sagan's The Pale Blue, the most eerie of them all, saw Earth from a distance of 3.8 billion miles. It continues to be the farthest depiction of our planet ever captured. Earth is hardly visible in the picture, its brightness veiled by sunlight reflecting off the lens of the camera. It doesn't even take up a whole pixel. According to Spilker, Sagan put a lot of effort into persuading NASA that it was worthwhile to take a closer look at the pale blue dot and realize how little it actually was. Sagan passed away in 1996. Voyager 1 entered interstellar space on August 25, 2012, marking the passage through the heliopause, the boundary separating the Sun's solar wind, as a testament to the persistence and dedication of scientists such as Carl Sagan. Voyager 2 followed suit in 2018. The two spacecraft are currently speeding across the solar system's vast outer regions. To put it another way, astronomers could never have imagined the Voyagers, yet their incredible adventures are far from done. Voyager 1 is now the farthest human object from Earth, having traveled over 15 billion miles at a speed of about 38,000 miles per hour. Like an uncle who has been granted an exceptionally long life or an old automobile that keeps running, the robotic spaceship is an endless superachiever. It has attracted space enthusiasts worldwide in the process. NASA's famous spacecraft continues to transmit signals to Earth from billions of miles away in the depths of space, providing fresh perspectives on some of the major enigmas of interstellar travel. These days, both Voyagers are so distant from Earth that it takes about 23 hours for a one-way radio transmission traveling at the speed of light to reach Voyager 1, and more than 19 hours to reach Voyager 2. They advance by an additional 3 to 4 light seconds each day. NASA's Deep Space Network, a triad of monitoring complexes positioned all around the world that allow continuous contact with spacecraft while Earth spins, is their only means of connection with Earth. The Voyager's transmissions are getting progressively weaker as they move away from us over time and space. Even nonetheless, the murmurs have completely changed scientists' assumptions about what the Voyagers would discover when they began their interstellar trip. The scant observations from the Voyager mission have shown a complicated dynamic structure created by the interaction of the greater headwinds in the interstellar medium with the exhalations of our Sun. Both initially traveled across a zone known as the transitional heliopause border, where the interstellar medium and solar wind forces are delicately balancing each other out. The region beyond the heliopause is mostly unexplored, shaped by particle showers from the previous violent deaths of giant stars and galactic magnetic fields. The best way to describe our heliosphere is maybe as a windsock that, as our solar system passes through the Milky Way, extends a long, undulating tail behind it. On the other hand, it may resemble a straightforward bubble or anything in between these two scenarios, a croissant-shaped structure with two tapering trailing lobes. It's unknown right now, but one thing is for sure: most of the high-energy cosmic rays that bombard our region of the galaxy are blocked from reaching us by the heliosphere. These rays have the power to destroy the cellular machinery at the core of Earth's biosphere and change the climate on our brittle planet. Therefore, in a manner, the solution to the riddle of how life began on a little planet orbiting an ordinary yellow star may lie somewhere, almost unfathomably far away, at the uncharted boundaries of our solar system. Following this, more data from Voyager over the next years might include vital information on the universe's beginnings for life. But what is the potential duration of the Voyagers? Perhaps we can have the missions extended until the 2030s if all goes according to plan. It's the limit. It all relies on the power. However, the Voyager's adventures will carry on even after they are utterly silenced. Voyager 1 will reach Proxima Centauri, our closest neighbor star, in 16,700 years, followed by Voyager 2 3,600 years later. After that, they will spend millions of years circling the galaxy. Long after the heliosphere has vanished and our Sun has disintegrated, they will still remain in the universe, essentially undamaged. Not to mention one dot of light blue. They might be able to deliver one last message throughout their journey. It won't be sent by radio, and if it is, it won't be heard by human beings. Two recordings, another type of antiquated technology, are used to convey the message. These aren't your typical plastic ones, of course. They're composed of copper that has been gold-coated and sealed inside an aluminum shell. Images and sounds intended to provide a feel of the environment from which the Voyagers originated are encoded in the grooves of the so-called golden records. In addition to the sounds of crickets, rain, and a mother kissing her child, there are images of kids, dolphins, dancers, and sunsets. 90 minutes of music feature Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good. Jimmy Carter, the U.S. president at the time the Voyagers were launched, also says, "We cast this message into the cosmos. We hope someday, having solved the problems we face, to join a community of galactic civilizations." This record represents our hope and our determination and our goodwill in a vast and awesome universe. The golden records are noteworthy for having an extremely extended shelf life. According to some astounding calculations, the chances of the golden record surviving extend beyond both the probable extinction of humanity and the collision of the Milky Way with the nearby Andromeda Galaxy, past even the death of the majority of celebs. This implies that one of the greatest cosmic riddles may eventually be revealed through the archives of the Voyagers. Throughout the many years that mankind has been studying the universe, we are the first to know with certainty that there are planets galore among the stars beyond our Sun. They are found in many different forms, and most of them are around the size of the Earth. However, we have not yet found any proof of extraterrestrial life. Is life in the universe easily starting and widespread, or is it extremely uncommon? However, answering one question just raises others, as with most scientific inquiries: which of these exoplanets, if any, are home to life? How long does life endure, and how fast does it begin? The Fermi paradox is the moniker given to the unsettling quiet of the cosmos. Where is everybody? Is a famous question made by physicist Enrico Fermi. The billions of years that the cosmos has existed provide sophisticated technological life forms plenty of time to transit the galaxy, even at sluggish speeds. Why then is the universe so silent? In the meanwhile, some of the variables in the hotly contested Drake equation, a series of numbers that might eventually indicate the number of sentient civilizations we should anticipate to find, have been filled in by exoplanet discoveries during the past 20 years. The majority of its parameters, such as the percentage of planets having life, intelligent life, and observable technology, are still undefined. However, the equation itself implies that we could find a solution eventually. Compared to Fermi's quiet, it seems at least a little more optimistic. The Drake equation was a significant scientific breakthrough when it was initially proposed, and it offers many fascinating insights. How many intelligent spacefaring civilizations exist in our galaxy today? Was one seemingly unanswerable question that was for the first time divided into a manageable number that we could imagine answering one at a time. The rate of star formation in the Milky Way, the proportion of stars with planets, the average number of potentially life-supporting planets around stars with planets, the percentage of potentially life-supporting planets that end up with life, the percentage of planets that have life and eventually develop intelligent life, the percentage of intelligently inhabited planets that emit detectable signals, and the duration of time that such civilizations continue to emit those signals are few examples of the things we could measure or estimate. An estimate of the number of active civilizations that we may be able to identify today will result from multiplying all of those factors. But right away, we encounter a couple significant issues. First off, we actually know rather well the rate at which stars develop in the Milky Way because we have measured it. Unfortunately, you would end up with essentially no stars if you increased that star formation rate by the universe's age since the hot Big Bang. You would figure that throughout the course of our cosmic history, the Milky Way should have created a total of about 10 billion stars. I understand that while 10 billion may seem like a large figure, it actually represents just 2 to 3% of the estimated 400 billion stars in our galaxy. Luckily, the reason this approach of figuring out how many stars we've formed, which you would think would give you the entire number of stars in the galaxy, is so utterly incorrect is simple to see. The apparent explanation on the surface is that the rate of star creation has fluctuated over the course of the cosmos. In reality, scientists now know that stars did not develop in the first 200 million years or so of the universe's existence. Thus, we now know that star production peaked after rising for the first 3 billion years of the universe's history, then declined thereafter. We have likely seen star formation bursts locally when we have absorbed smaller satellite galaxies, and we may even be beginning to see another burst as the Magellanic Clouds and Andromeda pull on the gas, dust, and other neutral matter in our own galaxy through their gravitational pull. However, that is only the surface explanation for the Drake equation's current problems. The fundamental explanation is because the Drake equation was based on an assumption about the cosmos at the time it was proposed, which we now know is incorrect. It made the assumption that the cosmos was timeless and unchanging. The universe has not existed in a steady state, where it is unchanging over time, but rather has evolved from a hot, dense, energetic, and rapidly expanding state. A hot Big Bang that occurred over a finite duration in our cosmic past, as we discovered just a few years after Frank Drake first proposed his equation. Rather, a far more fruitful path would be to compute the quantities we can presently reasonably speak about, then proceed as responsibly as possible towards the enormous cosmic unknowns. In contrast to the circumstances that existed around 60 years ago, when the Drake equation was initially put forth, we currently possess a superb understanding of the nature of our universe, encompassing both the Milky Way and the local group. We know what the different populations of stars are that are out there, and we also know what kinds of processes lead to the formation of heavy elements, rocky planets, and the potential for complex chemistry and significant reactions, like the synthesis of energy-storing molecules from nothing more complex than the common building blocks and starlight. Additionally, a great deal of knowledge has been gained on the kinds and numbers of exoplanets, or planets orbiting stars other than our own. Only 30 years ago were we finding our first planets near stars other than the Sun. However, as of July 2024, there are around 5,700 verified exoplanets. Indeed, there exist biases in our data since we tend to identify the planets that are most easily detectable. However, we have mechanisms in place to compensate for these biases. We really have some wonderful data here in our present Milky Way that we can use instead of speculating about how many stars develop, how many have planets, how many planets per system have the potential for life, etc. We already know the number of stars, the distribution of star populations, the number of planets around each star, the proportion of planets with elements that may support sophisticated chemistry, and the number of planets that could support life. From this point of view, estimating the number of possibly habitable planets in our galaxy is really rather simple. Indeed, there are several methods in which we may carry out that computation to demonstrate the versatility of our knowledge base. 80% of the Milky Way's 400 billion stars are red dwarfs, 18% are similar to our Sun, and the remaining 1 or 2% are too large and too brief in life to be of any significance to life. To the best of our knowledge, each solar system has between 5 and 10 planets, of which 1 or 2 are thought to be in the dubious habitable zone surrounding each star. We estimate that 20% or so of the planets around Sun-like stars are Earth-sized, and that a higher proportion of planets orbiting more frequent red dwarf stars are terrestrial. The number of stars, 400 billion, the fraction of those planets that are Earth-like in size, 0.20, the number of expected potentially habitable zone planets per relevant star, 1.5, and the proportion of those planets that are Sun-like enough to support life, 0.18, can all be multiplied if we make the conservative assumption that red dwarf systems are not habitable at all, but Sun-like systems are. Next, we calculate that there may be 21.6 billion habitable planets in the Milky Way. Using so many major figures is pointless, 20 billion is plenty. Additionally, we must keep in mind that there are ambiguities in all of these figures. Just 200 billion stars, or half of our estimate, may exist. Although the amount is small, less than 10% for sure, some stars may not have enough metals, or what astronomers refer to as the heavy elements in the cosmos, for planets to support life. It is possible that certain stars lack planets, although this is a very tiny percentage, less than 20% to be exact. Add another 33% uncertainty to our estimate in case the habitable zone turns out to be wider or smaller than we initially believed. Furthermore, our sample of exoplanets at the lower end of the mass radius part has been inadequate. We're not sure how accurate our estimate of 20% Earth-like size is, so we'll allow for a 25% margin of error. Overall, the number of possibly habitable planets in the Milky Way may be as high as 50 billion, or it may be as low as 5 billion. That number might climb tenfold if red dwarf systems are also possibly habitable. However, many of the issues we have previously been concerned about are probably not very important in the long run. Examples include whether a planet has a major moon or not, whether it contains a planet similar to Jupiter in its stellar system, whether it is near or far from the galactic center, and whether it is a part of a singlet or multi-star system. Beyond that, though, there are still some very significant unknowns about which we know incredibly little about the universe. Asteroids, gas in the galactic center, outflows surrounding large newly formed stars, and even the atmospheres and surfaces of other planets and moons in our solar system are all known to contain the elements necessary for life. What percentage of possibly habitable planets, though, have all the necessary components yet life actually evolved from non-life? Carl Sagan stated that the amount he provided, 0.10%, in his initial Cosmos series was cautious. It's not always the case like that. Just because life emerged early in Earth's history does not imply that a sizable portion of planets genuinely have or have ever had life on them. Life might be challenging. The probability that life emerges from non-life might be close to 100%, 10%, 1%, 0.01%, or 1 in a million. How likely is it that life would have emerged and flourished on Earth if we could turn back time and start the planet over? It's amazing how ignorant we are. In a similar vein, how often does life actually emerge and then perish versus how frequently does it persist for many billions of years? How often does it stay in an extremely basic stage, incapable of becoming complex, differentiating, multicellular, or reproducing sexually? How frequently does life on Earth genuinely start to resemble itself at the beginning of the Cambrian explosion, even after billions of years? Once more, we have no idea how this might operate. It makes sense if you calculated that it happened 10% of the time. Yet 90% of the time, it also is. And in 0.11% of cases, it is. If we make a bold claim without any observational or experimental data to support it, we are just fooling ourselves. Moreover, we know that it took more than 500 million years for a species to emerge that would develop sophisticated technology, even after life on Earth became complex, differentiated, multicellular, and sexually reproducing. And that was probably just the product of pure luck. How frequently does that happen? Is this an uncommon enough event to be compared to winning the Powerball lottery 5 times in a row, or does this likelihood make more sense when expressed in percentages? Moreover, how long is that high-tech existence going to last? Is it ever able to develop into a multi-planet or even interplanetary society, or does it go from being highly developed to being extinct really quickly? Our current level of uncertainty is so great that it is quite plausible that humans may be the sole sentient species not just in the Milky Way but across the entire observable universe, which most likely has a star count greater than 1 trillion times that of our own galaxy. With reasonable confidence, we estimate that there are around 20 billion Earth-sized planets, assuming an Earth-like atmosphere, that are composed of elements comparable to our own and spaced far enough from their parent star to support liquid water on their surfaces. However, how can we connect with aliens if they are real? AI might be able to assist. The craze for AI has taken over our economy and is about to spread beyond Earth to invading spaceships as well. AI also holds the prospect of reevaluating long-held expectations for space travel, such as the discovery that humans are not alone in the universe, just like it does on Earth. The development of AI explains this goal. Large language models, or LLMs, are built on the Transformer Neural Network architecture, which was first introduced in 2017. These models, which are transforming our world, were trained on internet-scale datasets and include a wealth of human knowledge. The International Monetary Fund estimates that they will have an impact on over 40% of jobs worldwide. But can we actually interact with hypothetically sophisticated civilizations using this technology? To be honest, this is a bold and maybe dangerous concept elsewhere, as hostile aliens might abuse this knowledge. Nevertheless, considering recent findings, it's a conversation worth beginning. There are a plethora of exoplanets in our galaxy, as demonstrated by space observatories like Kepler and the Transiting Exoplanet Survey Satellite, TESS. At least 300 million of them are thought to resemble Earth and may contain liquid water. We think that there may be sophisticated civilizations on a few of these worlds that are interested in getting to know us and our ways. Smaller open-source language models, like Mistral AI's Mixel 88X22b and Meta's Llama 370b, would enable training with selected datasets for interplanetary communication. Llama 370b is typically 130 gigabytes in size, making it quite large to send error-free over light years. Nevertheless, we were able to compress it into a few megabytes without sacrificing its functionality thanks to a method known as quantization. It would enable the AI to function independently without an internet connection, which is vital for interplanetary communication. We have two main methods, assuming we wish to transmit these LLMs to extraterrestrials: radio transmission, which is wide and sluggish, and laser communication, which is directional and quick. NASA's Lunar Reconnaissance Orbiter can transmit data at up to 100 megabits per second downlink over radio. This indicates that sending the whole full-size Llama 370b model to the Moon would take around 30 minutes. Data speeds as high as 622 megabits per second have been reached by the Lunar Laser Communications demonstration, cutting the transmission time down to around 5 minutes. Overcoming the great distances between stars, signal attenuation, and existing technology limitations is necessary to contact intelligent civilizations beyond the Moon. NASA's Psyche mission, for example, has a prototype laser interplanetary communication system. It launched last year toward an asteroid that is rich in metal. A few hundred megabits per second is the data rate that laser technology has attained. But using present technology, interstellar communication would probably slow down to 100 bits per second, meaning it would take hundreds of years to convey an artificial intelligence to Alpha Centauri, our closest neighboring star system, which is located a little over 4 light-years from Earth. Alternatively, as was previously mentioned, we may send a carefully selected and smaller model in less than 20 years that would only be a few megabytes in size, making it a mission that is doable for mankind. It would produce noises, visuals, and text as well. Historians, philosophers, scholars, and other specialists should decide on its personality, substance, and tone in order to reflect mankind as a whole. Another strategy to boost transmission rates is to use stronger lasers. We could send a lot of data over many light years if, as one of the breakthrough efforts suggested, we combined numerous 10 kilowatts lasers to create a transmitter with a 100 gigawatts power. And very rapid interstellar communication system might be developed by utilizing the sun as a gravitational lens. According to a different cutting-edge proposal, beyond Pluto's orbit, at 550 astronomical units, AU, or 82 billion miles, from the Sun, we would require a laser-equipped spacecraft. A more traditional approach would be to outfit each space voyage with a basic ruggedized onboard computer that houses a carefully selected LLM and an interface for interacting with it. This digital time capsule method will honor the history of the analog Voyager golden record while also extending it organically. The meticulously chosen pictures, sounds, music, and words on the gold-plated copper disc were meant to tell extraterrestrials about the history of our planet. Sometime in the far future, an advanced civilization could come across a spaceship that is outfitted with an antiquated computer or receive a signal that instructs it to reconstruct its artificial intelligence. By indirectly communicating with these life forms, we may show them that we are not alone and that there was once a human civilization that was possibly still extant and not all that different from their own. It can also expose our past, our goals, and our essence as a technological race. Now is the moment to take use of our AI developments to usher in a new era of intergalactic communication. Our legacy will live on even if we do not, since we will be able to communicate with alien intelligences through the launch of carefully selected big language models into space. Do you enjoy this video? Please like and comment below. Turn on the notification bell to get notifications for videos like this.